I am Sourav. I welcome you all to the live YouTube session from IMS Academy. Now my dear friends, you must be knowing that hardly October, November, December, January, 3 to 4 months are left, and if I just keep reserve 15 days of January for revision and test series, so hardly 3 to 3.5 months are effectively it's left. And you also must be knowing that now the festival season also starts, so it becomes your responsibility to steal your time from the festival days and just try to focus more and more in your preparation. It will be difficult to maintain your focus, to maintain your dedication, to maintain your consistency, but this is where some students will come out as toppers, and some of you might not even qualify or just not get whatever you want to achieve. So my dear friends, this time problem solving becomes very important, and in this respect, in this regard, obviously we will be coming up with more and more problems, gate booster sessions, challenging series, many series will come out, come, so that your preparation is more and more numerical oriented. But today what we are going to do, we are going to just revisit the questions of GATE 2024 and try to figure out the important topics. Now revisit the PYQs of 2024 for HT and IE, that is the heat transfer and industrial engineering, and we will try to figure out that what are some of the very important topics when it comes to IE and HT, and what you can do, you can focus more and more on those topics, right? Before I start with the questions, let me tell you that industrial engineering and heat transfer came for a combined 15 marks. Yes, 15 marks in GATE 2024, and it's a huge number considering that HT and IE is pretty straightforward subject. So good evening, Matan. Yes. So considering that IE and HT is a pretty straightforward subject, as far as GATE is concerned, that's a huge number. So I would request you that whatever your strategy be regarding the preparation, don't leave out HT and IE. Those are marks fetching, and those subjects can simply boost your score. So my dear friends, without wasting any time, let us straight away get to the point and let's discuss the questions. So my dear friends, you can see that there is a question from conduction, and you know that conduction is very important for GATE. So the question is, a plain solid slab of thickness L as shown in the figure has thermal conductivity K that varies with the spatial coordinate x as this, where A and B are positive constants. The slab walls are maintained at fixed temperatures of T at x equal to 0 is 0 and T at x equal to L is T naught, which is given over there. The slab has no internal heat sources. Well, that means no heat generation is there. Considering 1D heat transfer, which one of the following plots qualitatively depicts the steady state temperature distribution within the slab? And these are some of the options that you can see. So my dear friends, just don't blindly and do the guesswork that this is going to be the answer, this may be the answer, that may be the answer. No, you should have a very solid proof that yes, this is going to be my answer. Now why I am saying that, because most of you would think that it may be a straight line, it may be a quadratic, it may be a cubic, but what can be the answer? So first of all, you should know that it is a one-dimensional heat transfer. Yes, that means varies only with respect to x. No generation is there, and again it's a steady state case. Yes, it's a steady state case. So you know that you have that very long 3D equation, conduction equation with you. So d by dx, d2t by dx square, and k I was taking it outside earlier. For example, if I would have taken k outside and then d2t by dx square is equal to 0, I would have made. But this is not the case. This I cannot apply. Why? Because here you assume that k is not dependent with respect to x. K is not dependent with respect to x, but here clearly has been given that k is dependent with respect to x in the form of a plus bx. So I cannot take this out. So d by dx kx and dt by dx is equal to 0. I will have to start my problem from here. So d of kx dt by dx is equal to 0 if you integrate both the sides. So differentiation of something, so this will come out as it is, and differentiation of this is 0, that means this one must have been a constant. So you know, from here I can say dt by dx is c1 by kx, and kx is what? A plus bx. Kx is what? A plus bx. So dt is equal to c1 by a plus bx into dx, and if you simply integrate, so t is equal to, now what is the integration? c1 ln a plus bx, and it will be divided by b plus c2. So my dear friends, this is going to be the profile. And what is the variation? What is the variation? This is going to be the profile. And how t is varying with x? T varies logarithmically with respect to x. So which is the logarithmic curve? Out of the 4, which is the logarithmic curve? So B is going to be the logarithmic curve. This is the one which is resembling the logarithm curve. So most of you would straight away, you can, tick mark the straight line or the which one is looking like an exponential, because these are some of the common curves, but logarithm can also be the one. So I hope you got the solution. B, B is the correct answer. This is all fine. The working is all fine. Let's move to the next question. Yes. So please go through the question once. So the question says that consider incompressible laminar flow over a flat plate with free stream velocity of u infinite. The Nusselt number corresponding to this flow velocity is nu1. If the free stream velocity is doubled, the Nusselt number changes to nu2. Now choose the correct option for nu2 by nu1. So my dear friends, flat plate is very important from the examination perspective, and it is the known topics, known areas of heat transfer that makes it a very important subject. For example, anyone would say you that from flat plate question is going to come in the examination, whether 1 mark or 2 mark, right? So for laminar flow over flat plate, for laminar flow over flat plate, So this will come under forced convection. Pipe flow is also there, for forced convection. Internal flow, that is, okay, this is external flow. So for laminar flow over flat plate, local Nusselt number is what? 0.332, Reynolds number x to the power half, Prandtl number to the power 1 by 3. So tell me that he is asking he wants us to find the relationship for Nusselt number with free stream velocity. Now velocity doesn't come in Prandtl number, velocity comes in Reynolds number. So rho u infinite x by mu to the power 1 by 2 and Prandtl number to the power 1 by 3. So how does Nusselt number varies with respect to x? Sorry, free stream velocity. It is proportional to, just a minute. It is proportional to u infinite to the power half. So this is what we have to catch. Nusselt number is proportional to u infinite to the power half. So if we want to write, we can write for two Nusselt numbers nu1 by nu2, or let me straight away write, nu2 he is asking, nu2 he is asking. nu2 by nu1 I can write as u infinite 2 by u infinite 1 to the power 1 by 2. And what he is saying, that the free stream velocity gets doubled. So u21 is twice that u infinite 1 . So this gets cancelled, and this is nothing but root of 2. So nu2 by nu1 is root 2, that is A is the correct answer. A is the correct answer. A is the correct answer. Fine. So, as I said, that flat plates, flow over flat plates, is very important as far as your HT is concerned, and these are some of the cost benefit ratio of such topics, of such chapters, such subjects like HT is very, very high. You have to do it at any cost. Okay. So that being said, let us move towards the next question. Please go through it. Okay. So what he is saying, consider a slab of 20 mm thickness. So he has given already the figure. There is a uniform heat generation of Q dot as 100 megawatt per meter cube inside the slab. So it's a question of heat generation. The left and right faces of the slab are maintained at 150 degrees centigrade and 110 degrees centigrade respectively. Very good. The plate has a constant K of 200 watt per meter Kelvin. Considering a 1D steady state heat conduction, the location of the maximum temperature from the left face will be what? So my dear friends, again I want to tell you that that heat generation is very important from conduction, and it's a known thing, everyone knows it, still somehow we are not able to revise it in a proper way. Now what we have to do, there is there are two ways in conduction, the heat generation in which you can cope up with. One, if you straight away learn all the important formulas, the derived formulas, but I won't recommend you that. I would simply recommend you write the basic equation. d2t by dx square plus q dot by k, assuming k is constant, is equal to 0. Now you would know that if it is all coming from the big 3D equation, generalized equation that we derive in the beginning. So this is it. Okay. So this is what we have to simplify and apply the boundary conditions and then get the answer. So d2t by dx square is equal to minus q dot by k. So what I can do over, so let me go to the next page. So dt by dx is equal to minus q dot by k into dx. So if I integrate both the sides, so d of something, that something comes out, minus q dot by k into x plus a constant of integration c1. Again I can write it in this way, d of t is equal to minus q dot by k x plus c1 into dx. And again if you integrate both the sides, so t comes out and this is minus q dot x square by 2k plus c1 x plus c2. So this is the temperature profile. The variation is parabolic in nature, and you can see that there are two constants, c1 and c2. So the next step is determination of constants. So he has given that at the left face it is 150 degrees centigrade. So at x equal to 0, the temperature is 150 degrees centigrade. So when you substitute 0, so from here C2 comes out to be 150. C2 comes out to be 150. So I can just modify or update the equation as minus q dot x square by 2k plus c1x plus 150. And then he told that from everything we are calculating is from the left face. So at x equal to 0.2 meter, 0.2 meter, 20 by 1000, 0.02 meter, sorry, 0.02 meter, temperature is 110 degree centigrade. Yes, we have to substitute in meter only. If you are thinking that, sir, can we substitute in millimeter? No. Why? Because q dot we will substitute in terms of meter cube. So meter should be there. Okay. See, k value is also in terms of meter. So yes, you have to convert that in meter. So at x equal to 0.02 meter, the temperature is 110 degrees centigrade, 110 degrees centigrade. So if you just substitute 110, so minus q dot, so q dot also we need to, what is q dot? 100 megawatt. So 100 and into 10 to the power 3, because the units I will keep it in kilowatt. So 110 to the power kilowatt, and x is 0.02 square by 2 into, what is k? K is coming out to be 200. 2 into 200 watt per meter Kelvin plus C1 into x is 0.02 and plus it is 150, plus it is 150, plus it is 150. Okay. So, I thought that this is in kilowatt per meter Kelvin, so it is in watt per meter Kelvin. So, I will have to see, this is watt, so this also needs to be in watt. So, not 10 to the power 3, it should be 10 to the power 6. It should be 10 to the power 6. It should be 10 to the power 6. Yes, this is correct. So, now if you solve this, you will get your C1 value to be, now you have to check by calc. The C1 value will come out to be 3000. The C1 value will come out to be 3000. So, now we have the C1, C2 values, and finally what we can do, we can just put the values, but what he is asking we have to find out. He is asking the location of maximum temperature from the left face. Now, one thing is very important for maximum temperature. For maximum temperature, dt by dx, or minimum temperature also, dt by dx must be 0. So, dt by dx, check the dt by dx equation, this is the dt by dx equation, simply substitute that as 0. So, q dot x by k is equal to C1. So, x equal to C1 into k by q dot, and if you put C1 value is 3000, k value is 200, yes, and then q dot value is 100 into 10 to the power 6, 100 into 10 to the power 6. So, if you solve this, you are going to get 0.006 meter, 0.006 meter if you solve this, and but he is asking in terms of millimeter, so that will be 6 millimeters, that is going to be 6 millimeter, that is going to be 6 millimeter, 6 millimeter, 6 millimeter is going to be the answer, right? Right? Is it clear? Okay. So, clearly you can see that conduction is such an important chapter. Already we have solved 1 mark question or 2 mark question from the conduction. So, yes, you have to do it, and it is for such direct topics that HT becomes a very important subject. You more or less even you can tell someone that these are the 10 topics from where question is going to come. Okay. So, let us check this question, a 2 mark question. Please go through it. So, what he is saying? He is saying that a condenser is used as an heat exchanger in a large steam power plant in which steam is condensed to a liquid water. So, that means it is a case of phase change. The condenser in a shell and tube heat exchanger, which consists of one shell and 20,000 tubes, water flows through each of the tube, now this is the one you have to catch. Each water flows, steam is the hotter fluid, water is the colder fluid, and for each of the tube, for one of the tube, and total how many tubes are given? 20,000 tubes are given. Somewhere it is going to come into picture. Each of the tube at the rate of 1 kg per second at an inlet temperature of 30, the steam in the condenser shell condenses at the rate of 430 kg per second at the temperature of 50 degrees centigrade. If the heat of vaporization is this and specific heat of water is this, the effectiveness of the heat exchanger is what? So yes, it's a good question, and you should know that he is talking about 2 points. He is talking about, the question is talking about, first of all, phase change is occurring. Then steam is the hotter fluid and water is the colder fluid. And one more thing, you might think that, sir, he hasn't mentioned that whether it's a parallel flow or a counter flow. So in phase change, the formulas for parallel, the formulas for counter, all are going to be the same, right? So all the things are given. So let me straight away just draw the the diagram. So this is going to be the phase change is occurring, and I am going to consider it's a case of parallel flow, because even if you can take counter, it is not going to matter. And this is the inlet temperature of the hotter fluid, and this is the outlet temperature of the hotter fluid, and both are given as 50. This is given as 50, and the inlet temperature of the cold fluid is 30, and we do not know what is the inlet temperature of the the cold fluid. So he is asking about effectiveness. So what is effectiveness? Effectiveness is actual heat divided by actual heat transfer divided by the maximum heat transfer. Actual heat transfer by maximum heat transfer. So in case of actual, so first of all, let me tell you what is the maximum heat transfer. So maximum heat transfer, we always write the MCP of the colder fluid, or the lower, the one which is having the lower heat capacity rate, that we write, right? And then the maximum temperature, that is always the TH inlet and the TC inlet. So over here, what is the heat capacity rate of the lower fluid? So which one is having a lower heat capacity rate? So always the one which is undergoing the phase change, its heat capacity rate is always the maximum. The heat capacity rate is always the maximum. So we will not consider the hotter one. So colder one, heat capacity rate is the maximum. Okay, the THI and TCI you also know. Now what is the actual heat? In terms of actual heat capacity, so here MCP and THI. So THI and THI and TCI, this is the actual, this is the maximum heat transfer, and for actual what he has given, the heat of vaporization is 2.326 megajoule per kg. Very good. And its mass flow rate is also given. So what is the mass flow rate? Mass flow rate is 430. Now you can also substitute for the colder fluid. But one thing is missing. In colder fluid, you have no idea about TCE. That is why I have all the details about the hotter fluid, and I am going to focus about that. So actual heat, so M dot into what is the the HFG, that is the latent heat. Whatever is the latent heat, I am going to substitute. So effectiveness equal to what is the heat transfer, the mass flow rate 430 for the hotter fluid, now it is in megajoule, but most of the information, all the information is given in terms of kilojoule. So I will convert it in kilojoule. So 2.326 into 10 to the power 3. 2.326 into 10 to the power 3. Now it has been converted to kilowatt. The entire thing is kilowatt. For the colder fluid, what is the mass flow rate? 1 kg per second. 1 kg per second. And what is the Cp value? Cp value is 4, that is fine. And maximum heat temperature is 50. Inlet of cold is 30. But my dear friends, it is for one tube. It is for one tube. And how many tubes he has given? 20,000 tubes. So this is going to be the catch in this problem. And if you solve this, you are going to get you are going to get 0.625. 0.625 is the correct answer. Is the correct answer, right? So I hope you are getting to know all these questions have come. Chalo. So the next question is going to tell you about asked from radiation heat transfer. Radiation heat transfer between two bodies, and from radiation heat transfer from two bodies, and again it's a very, very important question, very, very important question, an important concept. Again I can say that there is a very good chance, very, very good chance that from radiation heat transfer one question is going to pop up. Okay. So what the question is saying, consider a hemispherical furnace of dia 6 meter. Consider a hemispherical furnace of dia 6 meter. So clearly you can see with a flat base is there. The dome of the furnace has an emissivity of 0.7. Very good. And the flat base is a black body. Okay. So flat base, that base is the black body. The base and the dome are maintained at a uniform. So this is the dome, this is the base. Very good. So emissivity. So let me do one thing. Let me consider dome as the one, and the flat base as the two. So now it will become very easy to just so emissivity of 1, emissivity of dome, that is 1, is 0.7, and base is a black body, so emissivity is 1. The base and the dome are maintained at the temperatures of this. So temperature of 1, that is the dome, is 1200 Kelvin, and temperature of 2 is 300 Kelvin, no issues. Under steady state conditions, the rate of heat transfer from the dome to the base is what kilowatt. So Q from this, and Stephen Boltzmann is given. So now my dear friends, first of all, no need to get confused from this word that from the dome to the base. Why? Because it is a two body enclosure, and whether you find from dome to base or you find from base to dome, it is going to be the same answer, right? Now don't say that sir one will come out to be minus and plus. No, I am talking about the magnitude. Obviously if you get minus, you will write the magnitude only. Okay. So what is the general formula? Again my dear friends, I will tell you that no need to memorize any derived formula in such cases. Try to memorize more and more and more the general formulas, my dear friends. Okay. So the general formula between radiation heat transfer between two bodies is this. Yes or no? The general formula is this for any two bodies enclosure. So what we do, we can just multiply with A1 we can just multiply by A1 on both the numerator denominator. So this will become just, this will go one two plus this will become A1 by A2, and one A1 will go up, one A1 will go up. Okay. So if you start, okay, so what do we know? We know sigma, we know A1, T1, T2, epsilon and everything we know, but we don't know what is F12. So F12, reciprocity relation, using reciprocity relation, you can say A1 F12 is equal to A2 F21. So one is the dome, so that is 2 pi r square, and F12, we are here to find F12 actually, and the base area is pi r square. F21 value is 1 because it is a flat base. So pi r square gone, and F12 will come out to be 1 by 2. F12 will come out to be 1 by 2, and that is 0.5. That is 0.5. Okay. So Q12 is equal to sigma. Now we can put the values 7 into 10 to the power minus 8. 1 we have considered dome, so 2 pi r square. The surface area of hemisphere is 2 pi r square. So dia is 6, so it will be 3 meter. It will be 3 meter, 2 pi r square, that is a 3 meter, 3 square. And it is 1200 to the power 4 minus 300 to the power 4. By, now epsilon 1 is 0.7, so I can substitute by 0.7 plus 1 by, now F12 is coming as 0.5, so 0.5 you can put, plus 1 by minus epsilon 2 is a black body, so it is 1 by 1, and A1 and A2, although I know here 2 pi r square by pi r square, that is 2 pi r square by pi r square, but actually there is no need because this term is going to get 0. So if you solve this, my dear friends, and just simplify and do all those things, you are going to get, I am going to write the final answer, that is you will be getting 2726.9. 2726.9, but we have to mention unit also in kilowatt. Okay, kilowatt is important. Yes, he is asking in terms of kilowatt only. Fine. So this was all about your HT questions, and one question which was controversial, which was declared marks to all. That question I am not discussing right now. Now, when it's a wrong question, why to discuss? But it came from internal flow through pipe, case number mixed cases, that is constant heat flux and constant wall surface temperature, surface wall temperature case, and through that what I want to say is that that is also a very important topic, don't leave it, right. That is an unfortunate case that question, none of the options were actually correct. That being said, let us move towards some industrial questions. And what he is saying, a company orders gear in conditions identical to those considered in the economic order quantity model. You know that inventory is one of the most important chapters in the entire mechanical. The annual demand is 8,000 gears. So, annual demand is, the cost per order is rupees 300 and the holding cost is rupees 12 rupees per month. Why I am saying, circling, because annual demand is given, CH is given, so you need to maintain it in some, same, rupees 12 per month, same units. The company uses an order size that is 25% more than the optimal order quantity determined by the EOQ model. The percentage change in the total cost of ordering cost and inventory holding cost with respect to the optimum. So, it is a straightforward question, you just need to take care of the basic calculations and you will be able to get through the question. So, first of all, what we have to do, he is ordering on EOQ, case 1, he is ordering on EOQ. So, Q is equal to Q star, that is EOQ. So, what is EOQ? It is 2D C naught by CH, 2 into annual demand into holding cost, ordering cost, holding cost per month, so into 12, right. Okay. So, if you solve this, what we are going to get? If you solve this, you are going to get 182.57, 182.57. Now, finally, he is going to ask the percentage change in the variable cost, variable total cost. So, let me calculate total variable cost with respect to the EOQ, and you know that the formula is root over 2D C naught CH, root over 2D C naught CH. So, root over of 2D is 8,000, C naught is 300 and CH is 12 into 12. If you solve this, you are going to get rupees 26290.68. So, one part of the question we have done. Okay. Now, he is saying that if the order size is 25% more than the optimal order quantity. So, case 2 he is saying if Q dash is 1.25 times the Q star. So, 1.25 times and Q star is 182. So, what will be the new Q star? 228.21, 228.21, and now he is asking you to calculate the total variable cost for this Q star. Now, you know that you cannot apply the root 2D C naught CH formula. Why? Because it's not EOQ, it's a general quantity. So, we have to apply the general formula, and what is the general formula? Number of orders into the ordering cost plus average inventory into holding cost. So, 8,000 and Q is 228.21. See, you can round off also, I have no issues with that, you are not going to get that much deviation. In fact, you are not going to get any deviation. C naught is 300 plus Q is 228.21 by 2, and don't forget that you are actually taking CH. It's given in per month, but you have to make it in same unit as annual demand, right? So the final answer that you are going to get is 26947. 26947.75. So this is what you are going to get. So finally he will be asking you, he is asking you percentage change. Percentage change, you know that it is always with respect to, he is saying, he is asking with respect to the EOQ, with the optimal order quantity. So he is asking always the former one, the basic one, the base. Base over here is the EOQ. So we have to find with respect to the EOQ. So it will be 26947.75 minus this cost 26290.68 whole divided by 26290.68, and when you solve this you are going to approximately get 2.5%. Approximately you are going to get 2.5%. So A is the correct answer. A is the correct answer. Right? A is the correct answer. So I hope you are getting the solution and you are revising also with me. You are revising also with me. Okay. Now let us, again let me tell you that queuing theory is very important. Yes. So all those questions that I have taken today, actually if you ask me, these are some of the super hot topics, super important topics for GATE. Yes, this is what at this stage a student wants to know what is the, the most important topics, and these are some of the important topics, my dear friends, the questions that we are actually solving. Hi Rahul, how are you? So these are some of the very important topics that we are solving, right? And that being said, queuing theory is very important. So please, clarify your concepts in these topics. What I am asking is that please clarify your concepts as far as these topics are concerned, right? A queuing system has one single server workstation that admits an infinitely long queue. The rate of arrival of jobs to the queuing system follows the Poisson distribution. You know that Poisson distribution is there, and lambda is equal to 5 jobs per hour. Arrival follows Poisson distribution and service time follows exponential distribution. The service time of the server, it's given, is exponentially distributed with a mean of 6 minutes. With a mean of 6 minutes. Now what is the mean of 6 minutes? What is 6 minutes? If I ask you what is mean and what is 6 minutes? Mean means average, okay. But what is it? This is actually inter departure time. That means I am providing service at the rate of 6 minutes. Every 6 minutes I am leaving one person. This is the meaning of it. Are you getting the point? So lambda is equal to 5 jobs per hour. Mu will be, now tell me one thing, we have to write the departure rate, because for finding the question we have to find the surface utilization, that is rho. Lambda by mu, lambda and mu should be there. So if I am leaving every person every 6 minutes, so within 1 hour how many persons I will be leaving? This is the thing. So 6 minutes I am leaving every person, that is 1 person. So 60 minutes, that is 1 hour, I will be leaving 10 persons. That's simple as that. So mu is 10 jobs per hour. It means I'm not leaving person over here, actually I'm doing job. So if I'm doing one job every 6 minutes, so in 60 minutes I'll be doing 10 jobs. So what is rho? Rho is equal to lambda by mu. Lambda is 5, mu is 10. This is going to come as 0.5. So once you have rho and you know that whatever he asks, that will be whatever he asks, it will be in terms of rho only, whatever he asks. Okay, let's see. In steady state operation of the queuing system, the probability that the server is not busy. So probability that the server is not busy. Server is not busy. What is the meaning of it? The meaning is the server is idle. Server is idle. It is 1 minus rho formula, 1 minus 0.5, and that will be equal to 0.5. That will be equal to 0.5. That will be equal to 0.5. Right? Okay, very good. Now let's take one more question. It's close to 1 hour, so we'll be keeping it for 1 hour only. So what this question is saying, a set of jobs U, V, W, X, Y, Z arrive at time t equal to 0 to a production line consisting of 2 workstations in series. Sequencing scheduling is very important. Yes. Each job must be processed by both the workstations in sequence, that is first followed by the second. The process times for each job on each workstation in the production line is given below. Okay. The sequence in which these jobs must be processed so that the total make spend time is minimum. That means he is asking you to use Johnson's algorithm, not Hungarian algorithm. Hungarian algorithm is for assignment problems, so Johnson's algorithm. Very good. So my dear friends, what I would suggest for this problem is that you make columns. I know it, time will be very less, but if possible, quickly make the column. It will make your work very easy. So workstation 1, 5734 U, V, W, X, Y, Z. So write here U, V, W, X, Y, Z. 5734 573468, and then on the 46685 46685 7. Okay. Now it will make your job very easy. Now why I am saying that? We have to arrange as per the minimum time. As per the minimum time, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay. So just select which is the minimum time. Minimum time is 3. Minimum time is 3. So just take W from the left hand side. W is done. After that, select the minimum time. It will be 4. Anywhere 4 is there, no issues. Let me select this 4 first because corresponding sign is minimum. So 4 to 5 W, U is going to come from the right hand side because it is on the right hand table, right hand column. And then the next one is X. So X will come from here. So X is also done. 4, 4 done. Okay. Next one is 5. 5 is here, right hand side. So take it from the right hand side. Y is also done. After that is what? 6. 6 is on the right hand side. V. And it is 7. It should be come from right hand side. So W, X, Z, V, W, X, Z, W, X, Z, V, Y, U. V, Y, U. Yes. Option A is the correct one. W, X, Z, V, Y, U. Option is, this is the optimal sequence. This is the optimal sequence, right? Okay. So my dear friends, what I want to say is that do practice questions. We will be coming up with more such sessions, and keep practicing. You know, we will be coming up with so many gate booster sessions, and in case you want to join the live online program, you can contact with the number given, and in you can consider joining the Telegram for many more such quizzes and daily updates regarding the examinations, right? So soon I will be coming up with strategies to secure 60 marks at this stage, and with many more such sessions, right? So I hope you enjoyed the session, and for any doubt you can comment in the chat box. You can share it with your friends who are preparing for GATE, and anywhere it will be helpful for them. So with this, my dear friends, I will be ending the session. Again, do subscribe the channel, because this is the time that we will be coming up with many such sessions, and you are going to be benefited a lot. That much I can say. So rest, you keep preparing. Just maintain your focus. As I said, this is the festival season, and you might tend to get deviated from your preparation. So try to be focused, try to be dedicated, and then we'll see whatever happens. So thank you, take care, God bless.